We call main the entry point, and for your purposes it is. But it is not the first code that runs. Between the operating system loading your program and main getting control, there is a piece of code that the linker quietly added for you, traditionally called CRT0, C runtime, part 0. It does the housekeeping that the language standard promises but the hardware does not provide. It sets up the stack so that the first function call has somewhere to put its frame. It zeroes the BSS, which is what actually delivers that guarantee about static variables starting at 0. It puts the initialized static data where it belongs. It collects the command line arguments into argc and argv, and then it calls main. You never write this, you rarely see it, and you should know it is there because when a program crashes before printing anything, this is one of the places it could have happened. The same thing happens on the way out. When main returns, control goes back to that runtime code, and it has 3 jobs. It flushes the standard I/O buffers, and that is the step that actually writes your output, because printf normally buffers rather than writing immediately. It runs any functions you registered with at exit, in reverse order of registration, which is how a library gets a chance to tidy up. And then it calls the operating system's exit service, handing over the value main returned. Which is why returning 0 from main and calling exit with 0 arrive at the same destination. There is a practical lesson buried in that first bullet. If your program crashes hard, that flush never happens, and buffered output is lost, so the printf you were absolutely certain had run produces nothing on screen. That is not a mystery, it is a buffer that never made it to the terminal. For reasons this is worth the 2 minutes. First, it removes the magic. Static variables are 0 at startup because a loop somewhere zeroed the BSS, not because 0 is what memory naturally contains. Second, the buffering point we just made, missing output after a crash is a lost buffer, not proof that the line never executed. Third, that odd link error some people meet on their very first day, undefined reference to main, now makes complete sense. The runtime startup code contains a call to main, and if you have not defined one, that call has nothing to bind to. The linker is not asking you for an entry point out of politeness, something is genuinely trying to call it. And fourth, if you ever end up writing for a microcontroller, you may find yourself writing this startup code yourself. Because on bare metal there is nobody else to zero your BSS.